Square root of 54. We talked a little bit about square root on Thursday before I left, and it's as if you had a square that was 54 square units in the area. The square root is trying to find, well, what is the length of that square on one side? Again, that's what it means, okay? Using the cake method means if you think of a cake like this or a cake for a wedding, there are different layers or tiers. So we are going to find the prime factorization using tiers. T-I-E-R-S, not tears, crying tears. All right, so you take the number that's in the square root. You put that down on the bottom. Because when you're building a cake with different layers or tiers, you have to start on the bottom. This is a division bar. This is not a square root. Okay? So this is a division bar. And the only thing you can divide by are prime numbers. Okay? Prime numbers. Prime numbers. Anybody tell me what a prime number is? Does anybody recall? Prime number is a number whose factors are only one in itself. So when you think of 2, 2 is the smallest prime number because its only factors are 1 and 2. 1 times 2 is 2. The next one is 3. 1 times 3 is 3. 4 is not prime because it has 1 and 4, 2 and 2. So prime numbers only have 1 and the number itself. Then we have 5, 7, 11, 13, and there's many more, but these are the ones that we are going to be using primarily. So you can only divide by these prime numbers, okay? If it is an even number that you're starting with, I want you to divide by 2, okay? So an even number, you're going to divide by 2. If it is a number that ends in 5 or 0, then you're going to divide by 5. That's another prime number. If it's an odd number that doesn't end in a 5 or 0, then you want to divide by 3. Okay? And if it's a different number than those, then you can maybe try 7, 11, or something like that. And you'll see what I mean in a minute. Okay? But whatever is under the radical sign here, you put down as the bottom layer. So 54 is an even number. So let's divide by 2. 54 divided by 2 is 27. And yes, you're going to want to have a calculator near you. Okay? If you got extras, check behind you, check in front of you. See if there's any extras around. All right, 27. Is that even? No. Does it end in 5 or 0? No, so I can't divide by 5. Is it divisible by 3? Yes. So that's kind of what you're doing, or the order I would go. So 27 divided by 3 is 9. 9 is not even or ends in 5 or 0, but it's divisible by 3 again. 9 divided by 3 is 3. And 3 is divisible by 3, and that leaves you with 1. Once you reach 1, that's like the candle on top of the cake. So you know you have gotten all of them. These over here, this is called our prime factorization. Prime factorization. And remember, this is all part of trying to find the square root of 54. So I am going to rewrite that prime factorization as, starting with my smallest number, 1, 2, times, yes, we're multiplying when we're inside and under the radical sign, times 3 times 3 times 3. Okay? you are going to look for any pairs of numbers. For example, I have 2 3s. Well, that's because 3 times 3 is 9, and 9 is a perfect square where 3 is the square root. So for that, the square root of that 9 that is inside the square root of 54, that part is 3. So that one of those gets kicked out because that is the square root of 9. Now, this 2 and this 3 do not have a double partner. So I have to leave those as they are. And so my final answer is the 3 that's out front times the 2 times 3 underneath the radical, which is 6. So that is my simplified final answer for the square root of 54. Any questions on that? No? Okay. All right, let's go to the second one. Says to simplify the square root of 16 times the square root of 54. Hey, wait a minute. Square root of 54, we just found that, right? So we're not going to reinvent the wheel. Let's use that answer that we have. We already know square root of 54 is 3 times the square root of 6. Okay, so I'm just rewriting it in its simplified version. Okay, so this and this are the same. Now, square root of 16. What can you tell me about 16 and when you're trying to find the square root of it? It is even. Looking for a little bit more. You are absolutely right, though. That's good. If I were to draw a square that had an area of 16, do you know what the square root would be? What number times itself gives you 16? 4. So if you know that, it makes the problem really easy. Because we can say the square root of 16 is 4 times my simplified answer of the square root of 54, which is 3 times the square root of 6. And when you're multiplying these, you would multiply your constant 4 here times the number out front, and you would get 12 times the square root of 6. And if you know the square root of 16 is 4, great. But many of us probably don't know that right offhand, okay? So I'm going to show you how we can do it if you don't know all of that. We still should get the same answer. So I'm going to say this is this, or you can do what we're going to do below, okay? So we are still going to keep square root of 54 as 3 radical 6, or 3 times the square root of 6, because we found that in our first problem. But let's say we didn't know that square root of 16. So you still use the cake method. Start at the bottom with 16. Let's make that bottom layer. And as Debonair said, it's even. So if it's even, I know I can divide by 2. And then you are just dividing in these cake tiers. 16 divided by 2 is 8. You have to keep going until you have a 1 at the top. 8 is even. Divide by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. Wait, can I stop there? No. You have to go till you have a 1 at the top. 2 divided by 2 is 1. So the square root of 16, written in prime factorization, is all of these on the outside. Everything that you divided by that was a prime number now goes under the radical sign as 2 times 2 times 2 times 2. I need to simplify that. Okay? So I'm looking for pairs of numbers. So here's a pair. We know 2 times 2 is 4. If I would take the square root of 4, that's 2. So I'm going to kick that out. Here is another pair of 2's. I'm going to kick that out. And when you kick it out, you are taking the square root of those pairs of numbers. So the square root of 2 times 2 is 2 on the outside. That's for the first one. The square root of 2 times 2 is times 2 on the outside again. I don't have anything under the radical there. So 2 times 2 is 4. And that is for the square root of 16. So even if you didn't know that, you can find it using prime factorization. Multiply that by our 3 times the square root of 6. So you multiply constant times coefficient, your whole numbers. 4 times 3 is 12. And what you have left is times the square root of 6. So either way works. If you know what the square root is, great, use it. If you don't, use the cake method to find it. Okay? Questions on that? Okay, let's go to our notes. I think it's actually page 17. I left 15 up there, but I think it's 17. Please ask questions if you're not sure. Mm, 17. Okay, maybe it's 18. It's actually going to be 18. Yeah, so 17 covers part of what you should have gathered either from the video or from just writing down the notes. So it's actually page 18, okay? Sorry, one more page over. And if you didn't get to watch it again, watch it tonight, copy down the notes tonight. So multiplying square roots. Multiplying square roots. Eyes up here, on your papers, wherever, okay? We need to simplify the multiplication of the square root of 5 times the square root of 48, okay? I'm going to show you that we can actually multiply these together. Since they're both under the radical, we can multiply them under the radical sign, okay? And what is 5 times 48? 5 times 48 is 5 times 50, which is 250, minus 5 times 2. So that is 10. 250 minus that is 240. Check my math. Yep, that's right. Okay, so we're taking the square root of 240. Miss Dee Dee, that's a really large number. It is. Compared to what we usually do, yes. But we can do it. So start on the bottom layer of your cake with that number, 240. Okay? And we just need to divide. 240 is what kind of a number? Even. So that means I can divide by 2 and get 120. Victoria, are you awake? Okay. 120 is even. Divide by 2 to get 60. 60 is even. Divide by 2. Now, I could have stopped there because I could have, since it ends in A0, I could have been dividing by 5. But I just went with the evens, okay? It'll give you the same number either way. 60 divided by 2 is 30. 30 divided by 2 is 15. 15 is not even, so I can't divide by 2. It does end in 5, so I can divide by 3. Or since it ends in 5, I could divide by 5. Either one. I'll say 3 since you said 3. That gives me 5, and 5 is definitely divisible by 5 to give me that 1. So the prime factorization is all these numbers that we divided on the outside, and I circle them to help me say this is what needs to go under the radical. So it is 1, 2, 3, 4 2's multiplied with a 3 and a 5 under the radical. Find your pairs of numbers, because when you multiply 2 times 2 together, that actually gives you 4. And we know the square root of 4 is 2. So only 1 comes out. Here's another pair of 2's. So that comes out. So out in front, you only put the square root of those, which is 1 of the 2 numbers that are there. Only 1. So that's 2 times 2, and 3 and 5 don't have another partner or pair that is the same. They stay underneath under the radical. So simplifying this, I get 2 times 2 is 4 times the square root of 15. And that's your final answer. You also could have done this separately and said square root of 5 times square root of 48. Done the cake method, okay? Let me just show you really quickly. I'm going to say, or I could do the square root of 5, which if I do that with the cake method, it's just 5. Square root of 48. If I use that cake method, here's 48 divided by 2, 24, divide by 2, 12, divide by 2, 6, divide by 2, 3, and divide by 3 is 1. So this is the prime factorization for 48. I'm going to put it underneath. Maybe I'll put it above. I'll put it above. So that is 4 2's, 2 times 2 times 2 times 2 times a 3. So looking at these pairs, circle your pairs, but only one number comes out because you're finding the square root of those 2 pairs. So that is 2 times 2 times the square root of 3. This over here is just the square root of 5. So putting it all together, 2 times 2 is 4. And square root of 5 times square root of 3, you can put those together. They're under the radical. That is the square root of 15. There's no doubled number there, so that's your final answer, which is the same as when we multiplied it and got the larger number. Does everybody see what I'm saying? So you can multiply both together and get the large number, or you can multiply them separately, find your prime factorization using the cake method, and that gets your answer. Okay? All right, I want you to try to simplify the square root of 8 times the square root of 14. I want everybody to try that at your seats. So you can either multiply those numbers together and get one large number, or you can keep them separate and do 2 separate little cakes. Does that make sense? All right, see what you can do right there. Okay? Make one big cake by multiplying them together, or 2 small cakes. And let's see if we can simplify. Who needs a calculator? Calculator. Everybody here's got one. Go. Go. Are you feeling better? You were out some days, I know. Okay, how many went with trying the big cake? Let me see your hands if you went with the big cake. How many stayed with the 2 small cakes? How many didn't answer? Several. All right, so I'm going to do it with the big cake method first, okay? Might not be all the way done, but let's see how you started out. So square root of 8 times the square root of 14. I'm going to multiply those together and get 112. Thank you. So this is my big cake. 112 is going to go in the bottom layer. It's even. How do you know if something is even? Look at the last number. It has to be a 0, 2, 4, 6, 8, right? So this is an even number. Divide by 2, and I get 56. Divide by 2, I can divide that by 2 and get 28. Divide by 2, I get 14. Divide by 2, I get 7. Divide by 7, because 7 is prime. Remember, these all have to be prime, and I get my candle. So here is my prime factorization. Prime factors. So I rewrite this as 4 2s times 7. And I look for my pairs. So here's a pair of 2s. Here are a pair of 2s. You're essentially finding the square root of those doubled factors. So those get kicked out. Those get kicked out. Only one of the 2 gets pulled out front. Let me repeat that because this is very important. Only one of your 2 same factors gets pulled out, okay? So that's 2 times 2. And I have a 7 left over with no other partner. So my simplifying is 4 times the square root of 7. Those of you that did the cake, big cake, did you get 4 square root of 7? Nice. Good. Okay. You also could have done the smaller cakes. I could have done square root of 8 times the square root of 14. So start with 8. Divide by 2. 4 is divisible by 2. 2 is divisible by 2. And so square root of 8, 2 times 2 times 2, pull out a pair, and that simplifies to 2 times the square root of 2. 14 divide by 2 is 7. Divide by 7 is 1. So this simplifies to the square root of 2 times 7. I can't do either one of those, okay? But remember, we have to multiply these together. So I see the square root of 2 here and the square root of 2 here. So that's going to give me 2 times the square root of this 2, and that 7. Pull that pair out front. Gives me 2 times 2 times the square root of 7, which is 4 times the square root of 7. So we got the same answer whether you stay with the 2 small cakes and multiply those answers or the big cake. Okay? Now, let's add some variables. All right, first of all, let's do the coefficient. I feel pretty confident you can do that. So you need to take 50, the coefficient of that expression. Divide it by 2, or you could have divided it by 5. Same thing. I get 25. divided by 5. Remember, these are only prime numbers. Not Camille. Clavin. Latrell, you with me? Clavin, you with me? Clavin, can you like nudge him? Come on, stay with me. And so I get 5 here divided by 5 is 1. So my prime factorization for this 50 is 2 times 5 times 5. All right, listen very carefully, everybody. Eyes up here, okay? If you have a variable taken to an odd power, okay, a variable to an odd power, I want you to separate it into whatever that variable is to the first power times whatever that variable is to the whole number, in this case 3 minus 1, which gives you 2. So we're breaking it up into 2 smaller expressions. The first one is going to be whatever that variable is to the first power times whatever that variable is to the whatever the whole number is minus 1. So in this case, this is x to the first times x to the second. So everybody see what I did? That's if you have an odd number, okay? Then if you have a variable to an even number, so you might want to write this in, a variable to an even numbered power, I want you to take that exponent and divide it by 2. So y to the fourth is going to be y to the second, because 4 divided by 2 is 2, times y to the second. Okay? So I'm going to multiply this as y to the second times y to the second. Because remember, when you multiply 2 powers that have the same base, you keep the base and you add the exponents. So it's just dividing it into 2 smaller expressions. Now, this is my variable to an even power. So I'm going to take x to the second and divide that by 2 and make that x to the first times x to the first. I know this is a lot, just trust me. Now we are going to look and say, do I have any pairs that I can kick out front? Do I have any perfect squares under the square root? Yes, we do. We have 2 5s. From x squared, I now have 2 x's to the first power. And I have 2 y squareds that are going to get kicked out. Remember, you only choose one of each pair because those are the square roots. So 5 times 5 means 1 5 comes out front. Times x to the first times x to the first means 1 x to the first comes out front. Y squared times y squared, only 1 y squared comes out front. And what do I have left? Under the square root, I have a 2 and I have an x to the first power. So your final answer is 5x y squared times the square root of 2x. Okay. So again, let me just Let me do a few extra little things here. You don't have to write them down. But if under the radical sign you had x to the 8th power, if you have an even numbered exponent, divide this by 2 and make it x to the 4th times x to the 4th. And then when you have 2 of them, only 1 would come out. If I had x to the 15th power, we're going to change that. So it would be x to the 1st times x to the 14th. And then when you would have x to the 14th, divide that by 2. So it's x to the 1st times x to the 7th times x to the 7th, because you are finding essentially the square root of x to the 14th. Here's your pair. Only 1 comes out because you're looking for the square root, not the whole thing. So that would be x to the 7th times the square root of x. Okay? So it is something a little that you have to get used to. All right, let's do the last one, letter B, which is buried in here. So this is letter B. I have the square root of 20a squared b c to the 3rd power. What am I going to do first? What would I do first? Let's bake our cake and put the bottom tier, right? Let's find the square root of our coefficient 20. So start with 20. 20 is even. It also does end in a 0. Let's divide it by 5 because 5 is prime. And that gives me 4. 4 is even. Divide it by 2. You get 2. 2 is even. Divide it by 2. And there's my birthday candle. Do not include 1 with the birthday candle. So the prime factorization of 20 is 2 times 2 times 5. A squared. That a squared is even. Divide that by 2. A squared is the same as a to the 1st times a to the 1st, right? B, I only have one B. I'm running out of room. So I just keep that B in there. There's only one. And C to the 3rd is going to be C to the 1st times C squared. That C squared, if you take the square root out of something that is squared, that is C to the 1st and C to the 1st. So it's like C squared divided by 1. So find your pairs. I have a pair of 2s. So they're going to be pulled out front. I have a pair of A's. And I have this pair of C's from my C squared. So out front, I have a 2, a to the 1st, c, and what do I have left? Underneath the radical is a 5, which did not have a pair, a b, and you've got to look really closely because I'm running out of space here, and a c to the 1st. And so that is your final answer. Okay? Questions. What questions do you have? Not too bad? All right. So homework number 3 is in your packet. Let's go to homework number 3. It's going to be due on Wednesday. Due on Wednesday. Let's see if we can start some of these together. These are a lot simpler than the ones we even did just now in practice. Let's go down to number 3, down at the bottom. Number 3, this is on homework number 3, due on Wednesday. Let's jump down to number 3. We have the square root of 32, b to the 3rd power, okay? I need to start with that coefficient 32 as my bottom cake layer. So start dividing. You can only divide by primes. That's an even number, so I can divide by 2 and get 16. Another even number, divide by 2 and get 8. Divide by 2 and get 4. Divide by 2 and get 2. Divide by 2 and get 1. This is the prime factorization of 32, which we need. So this is going to be 2 times 2 times 2 times 2 times 2, b to the 3rd. That is an odd number, so I'm going to change that to b to the 1st times b to the what? What's this exponent going to be right here? 2, right? Because when you multiply powers that have the same base, you add the exponents. And 1 plus 2 gives you the 3. Now, this b squared, you can break that down. B squared is the same as b times b, right? So circle your pairs. There's a pair of 2's, pair of 2's, and this b squared is a pair of b's. Pull those out front. So only 1 comes out front. So that's a 2 times 2 times your b in front of the radical sign. Inside you have 2b, and simplifying it is 4b times the square root of 2b. And there you go. Okay? So this, you should be able to do all of the front side of homework number 3. And you can go all the way down to number 11. You would not be able to do 11, 12, 13, or 14, but you could do the 4 top ones on the back. Okay? Because those are multiplication. All right. So homework number 3, be working on that. Please get me homework 1 and 2. Use your notes if you have forgotten. Okay?